Welcome to a new video in my home automation series, and there's going to be another small step in the EV charge monitoring project that I've done, and I think this is probably like the third or fourth video in this basically mini series where I'm just adding a piece of functionality like every week or every other day. So I'm just building up on what I have done so far. So in probably one of the earliest video, I just explained how I created a new PCB project with an ESP and a RS485, so I can read a single phase energy monitoring. So that feeds into this Node-RED flow that you can see here. So it's just sending me data on the energy consumption, amps, currents, watts, on how much my EVSE is pulling from the grid. And based on this, I can tell whether the car is charging or not, when it started charging, when it finished charging. So it sends me all this information, and this is all working fine. But what I also wanted to do is I wanted to do these daily statistics, and that's what I have done since the last episode. And it's not really complicated. All I wanted to do basically is whenever it monitors that the charging started, and then when it says that the charging stopped because the current goes back to zero, then it calculates how much was the charge, and then the time, how much time elapsed, and the kilowatt hours. And I just wanted to add this up on a daily basis. So this is what I've done here. So if you remember from the previous video, there is an output here when the charging completed. So that's when the charging stopped. And I put everything, and this goes into this function node, which is going to calculate all the daily statistics. And by the way, let me just show you the end result, which is here. So it has two attribute objects, which is today and then the yesterday. So in today, it just adds up everything. So it calculates the time spent in charging in milliseconds. Also, there is like a human readable format, so it's 1 hour 24 minutes, and I charge 4.7576 kilowatt hours. So this is just basically the accumulated energy usage throughout the day if I have charge in multiple steps. And of course, it also counts the charge. Well, it's not really a charging, but if I turn the heating on remotely in the morning, then obviously would notice that if it's plugged in, then it gets the power from the grid. So that adds up to another, I don't know, half a kilowatt hour or something like that. So that's what it does. And then I said that I want the cutoff at 7 in the morning, not like midnight, but like 7 in the morning. So that's the charge for the last 24 hours. And then whenever this happens, it copies all the today stuff into the yesterday stuff. So yesterday I've charged 4.9 kilowatt hours. Today, since 7 a.m. I charged, that was 3.9 and 4.75 today. And then 7 a.m. in the morning, all this information will copy into yesterday. And just for basically debugging purposes, I am also storing all the previous charges in this array. And this is more for me to basically debug. So you can see that, okay, there was 1 hour 12 minutes here, and then there was another 11 minutes here. So that sort of adds up to 1 hour 24 minutes. And again, if I add up the numbers as well, so 4.17 plus 0.58, that is 4.76 or something like that. So at least I know that the calculation is working, because that was these two charges. And so that was basically I think that was the overnight charge, yeah. So started at, that was afternoon. And I think this short one was the morning one where that was the evening. Anyway, okay, so these two things that got logged. That's it. It doesn't get any easier than that. So what I have done in this function node is that the information comes in, so every time the charging completes. And I've also created this reset status on well, not 7, 8 o'clock in the morning every day. So it just sends a topic next day, so it knows that that's the time where it needs to reset the statistics and copy today into yesterday. So you can see that if so everything gets stored in this EV flow variable. So if it doesn't exist, then we create it, and then if it's the next day topic, then I delete yesterday, and if the today is not undefined, so if we have any data, then I copy today into yesterday, and I delete the today, and I also reset the charges, and I save the changes. Simple as that. And then for any other cases, it means that the charging just completed, and I received the data for at the end of the charge. And so what I do is, well, if the today doesn't exist because it's the first time, then I initialize it with 0 values, and then I just calculate the energy used, the time, and obviously that gets accumulated from the previous value, and the time, it just gets calculated from the accumulated charge time underscore millisec. And I save the last payload into the charges, so that's what you can see here, and I save the variable. That's it. And I also thought that, okay, we have this information, the daily thing. So what? So every time if the data is next day, then we might as well just save to a database. So I create a new payload, well, a new influx line command. I decided that I'm still using my measurement sensors, and the device is going to be EV, and then the fields is whatever I have in the yesterday. So that's the energy used and the charge time milliseconds, and the text as well. And we can see how this looks like. So if I quickly log into Influx, then okay, it is running. Explore. So it's the Node-RED bucket, and it's the measurement sensors and the device EV, and then the fields. Oh, okay, I need to probably just go like the past 2 days. Okay, so I have some data here, so you can see energy time. Oh, I can plot all 3 of them. Well, I won't be able to plot the text. And if you look at the data, then oh yeah, I can't use text. So you can see that these are the charge time in milliseconds, and the two the 3.90, that's the one that it was yesterday, and then well, the day before that was 3.25. So I have all this information, and of course at the end I would build some sort of Grafana dashboard, but I haven't done that, so probably that's going to be the next step, or the next stuff. Well, not the next, but the one after, because I think what I want to do next is I put all this information onto my touch panel where I can control the house, and that already has a screen for all the solar charging and consumption, that sort of screen. So probably I'm going to add something to that, and maybe there's going to be like a separate EV screen where I can see all the data that we could see in the flow now. So like the daily statistics and the current statistics, and so all this information. So I think that's going to be the next video, and probably the Grafana is going to be the last. But I think the Node-RED part is, well, it's not complete, but the logic itself is complete. So the only thing I am going to add here is extracting all the relevant information that I want to display in a touch panel, because I have to send it into separate registers into my PLC. So then the touch panel can just get the information of the PLC. So I'm just going to use the PLC as a central storage, and we can get the information from there. So I think there is going to be some stuff probably here and also here and also here, where I'm just going to get the data and then, you know, push this over to the PLC using Modbus TCP. But you know, that is specific to my setup. But I think this is, as far as the logic is concerned, is now probably complete. So with this video, I'm just going to copy this flow, and I'm going to put some sort of, I think it's going to be on the wiki as well. So if you need anything like this, or if you want to use part of this logic, then just go to the video description and you will find the link to this flow. But I think that will be all for today. Thanks for watching, and hopefully see you next video.